The work upon which this video is based was funded in part through a grant awarded by the Wood Education and Resource Center of the Northeastern Area State and Private Forestry of the U.S. Forest Service. Today, a range of modern logging equipment is utilized by loggers managing one of the world's most valued renewable resources. Loggers are always looking to improve production and profitability of their operation. This is especially true when access or terrain makes harvesting difficult. Providing an alternative to existing logging technology for challenging timber sales in the Great Lakes region is an excavator-based cable logging system. This system has a cable that extends over the hard-to-log area, which does not make felling the timber any easier, but can make removal of the timber to an accessible area safer, more environmentally friendly, less time-consuming, and more cost-efficient. It utilizes two 40-ton mobile excavators and is a viable option for loggers and landowners faced with challenging terrain. Developed by a man with more than 20 years of experience in forest harvesting and research and development, this system is not only user-friendly, but applicable to multiple types of harvesting situations.
The system got developed near Quebec City, where mills are surrounded by mountains and hills. At that time, those mills had to go over 2,000 miles away to get their wood on flat terrain. As we had a lot of wood in those mountains right by the mills, I wanted to log those places. That brought me to develop this mobility concept.
Probably the biggest advantage is there's a lot of landowners that don't want to manage their lands because they don't want conventional machinery on it. This gives them an option to where they can manage their lands and take the timber off and keep their forest healthy.
The excavator-based cable logging system lends itself nicely to a variety of logging applications, such as steep slopes, wooded swamp areas where other logging systems need dry or frozen conditions, and islands where accessibility makes other logging methods difficult at best.
I got approached by enterprises in Indonesia to harvest wetlands on flat terrains. We did it with much success. Therefore, a new market was open for the system, in addition to harvesting on slopes where the system works both ways, uphill or downhill.
A demonstration of the excavator-based cable logging system took place in a hilly area in Marinette County in northern Wisconsin. Timber in this area consisted of aspen, oak, red pine, and red maple.
It all reached maturity. The oak and the aspen, and oak and aspen do very well in sunlight, and the new growth is just going to be fantastic for wildlife and the timber management.
This 20-acre site is an old ski hill located on one of the highest points in the county, with slopes of up to 70% in some places. Two excavators with hydraulic winches and 48-foot towers or spars serve as the mobile anchors for this system. They are connected by a 1,500-foot main cable on which the self-propelled sky carriage travels. The sky carriage has a 71-horsepower diesel engine capable of traveling up to 1,200 feet a minute. Operation is possible with as few as 2 operators, in this case, one at the log deck and one positioned near the felled timber. All system functions are controlled remotely in turn by the 2 operators using battery-operated keypads with 12 clearly marked buttons that allow them to start or stop the engine and to set carriage and skidding cable speed. For safety, only one logger can operate the system at a time.
Safety is always number one on our jobs, and our records prove it. So logging it this way, it can be stopped on either end. The fellow hooking it or unhooking the cable can stop it for safety.
The skidding cable can be up to 300 feet in length, with multiple chokers at the end of it. The operator lowers the skidding cable until he is able to grab hold of it, and continues to lower it until it reaches the selected timber. Usually 3 or 4 good-sized trees were hauled during this particular demonstration. Average load capacity for this system is about a cord, or between 4,500 and 5,500 pounds. But average load weight can vary greatly depending on spacing and size of trees. When the load nears the excavator on the landing, the operator at the excavator takes over control of the load, bringing it to the landing and lowering the load to be released. Since the sky carriage can place the trees with precision at the landing, Product processing can be conducted in tandem with the removal process, as the landing will accommodate. The basic options for processing on the landing include using a chainsaw, harvester or processor, or slasher with delimber. Operators use the remote's radio communication as necessary. But very often, the sky carriage is simply returned for another load with no discussion at all. The simplicity and safety of this system is ideal. Similarly, its speed and efficiency make it a viable option.
We were going on this site about 251 yards up, and it was traveling the carriage was traveling in a minute and a half up. And it's bringing a turn of logs about every 5 minutes from the top, and from the middle of the mountain about every 3.5 minutes.
Fuel consumption for the sky carriage is typically about 1 gallon per hour. Simple math shows that if the sky carriage were to run for 2,000 hours a year at roughly a gallon of fuel an hour, it would use 2,000 gallons. At $4 a gallon, estimated annual fuel costs for the sky carriage would be $8,000. For this demonstration, the trees were hauled downhill because access made this the best option. However, trees can be cabled uphill or dropped in between the two excavators if there is a good access landing area.
We've done work on both water quality and on the amount of biomass needed to be left to keep different soil types healthy. And so by the tops breaking off and the stuff that naturally breaks off while skidding down like this, we're leaving about the amount we'd like out there to provide the nutrient for the next stand.
What makes the excavator-based cable logging system unique is its ability to be repositioned easily. The simple process begins by letting out the main cable to create slack. Then the entire tower, or spar, is lifted before the excavator starts to move.
This system, by being based off on excavators, the excavators have the weight to keep the tower upright to where you're not having to guy everything down. The more traditional cable systems, you would have a tower, but then you'd have to run 6 guy lines back to trees or buried, and it'll take anywhere from 4 to 8 hours to guy down a tower.
After arrival at its new anchor point, the tower, or spar, is lowered before taking up the slack in the main cable. For this demonstration, repositioning the excavator about 100 feet and getting it ready to resume work took just 2 minutes. When conditions such as this steep slope dictate, manual felling is a good, cost-effective option. In this case, 2 sawyers work the hill, positioned on either side of the main cable. Of course, the system can work with mechanized felling as well. A harvester or feller buncher could do the felling if the terrain conditions permitted. Again, one or both of the excavators can be moved quickly and easily to any area with more timber to pick up. Here we see the excavator at the top of the hill, moving into better position.
Between the speed and efficiency of this system and the safety that's pretty well built into it, I was impressed when I seen it the first time, and I remain impressed.
I guess overall, everybody that comes, including myself that's been here every day, is very, very impressed. And after you're looking at it, you're thinking of many, many other places where it would work very well. You know, like maybe islands on the Wisconsin River or islands on the Menominee River, or all over the UP or Wisconsin.
During the demonstration, a production analysis was conducted. In the 3 hours of study, the sky carriage made 46 turns and hauled a total of 128 trees, or just shy of 23 cords. That's approximately 8 cords an hour. If the team worked for 7 hours, they would be able to move more than 55 cords per day. If the team worked for 225 days, they'd be able to move nearly 12,500 cords per year. Taking a closer look at the sky carriage itself, this non-complicated piece of machinery consists of little more than the computer, engine, pulleys, cable, and frame. On this system, the middle pulley is stationary, and the 2 smaller outside pulleys can be easily removed. This allows for quick and easy placement or removal of the main cable. Operator training costs are minimal, since as little as 1 or 2 days are needed to train the operator on setup and operation. 3 semi-lowboy trucks are needed to transport the more than 100 tons of equipment. Here's how the cost analysis breaks down when factoring in the purchase and annual operation costs of an excavator-based cable logging system. Estimated purchase price for a system is $430,000. Using a 5-person hand-felling crew and moving the system approximately 12 times per year, the estimated cost per cord tree length at the landing would look something like this. Payments toward the unit, with a 5-year payoff at 7% interest, would be approximately $7.70 a cord. Labor, $15.88 a cord. Moving costs, $1.50 a cord. Annual cable replacement and routine maintenance, another $1.50. And fuel would be just $1, for a total of $27.58 a cord. The responsibilities and challenges loggers face are indeed great. The availability of the excavator-based cable logging system puts one more tool in the logger's toolbox for times when access or terrain become issues. For more information about this system, visit the Glacier Land Resource Conservation and Development Council's website, or contact Don Peterson at Renewable Resource Solutions. The demonstration and video was a cooperative effort of the U.S. Forest Service, River Country Resource Conservation and Development Council, Pomeroy Forest Products, Glacier Land Resource Conservation and Development Council, Teleforest, and the Wisconsin Department of Natural Resources.